Alright, fellas, today we're going to talk about scientific notation. Alright, scientific notation is a way of writing really big numbers or really small numbers, and an easier way using powers of 10. Okay, so you're going to use 10 to a certain exponent to write these numbers, basically without a whole bunch of zeros attached. Okay, so scientific notation looks like this. Okay, this c times 10 to the n. Okay, it's always going to look like that. The c here, has to be a number between 1 and 10. Okay, so it can be a decimal. So basically the smallest number that c could possibly be is 1. And the biggest number that could possibly be is 9.99999, so on and so forth. Okay, so it has to be somewhere between those. It can't be 0 point something, and it can't be 10 point something, or anything bigger. Right, and the n, right, n has to be an integer. But remember that an integer is basically a whole number. Okay, no decimals, but it can be both positive or negative. Alright, so it could be a whole number, it's got to be positive or negative for that n. Okay, so we're going to write some stuff in scientific notation here. Alright, quick examples. We've got 2 million here. Okay, 2 million, you've got 2 and then 6 zeros. Well, the way that we're going to write this, we're going to write it as 2 times 10 to a certain exponent. Now, every time exponents powers of 10, okay, if you have a positive number, it's basically moving the decimal place over to the right, and if you have a negative number, it's moving the decimal place over to the left. Okay, so let me show you what this looks like. We've got 2 here, right? 2 is right here, that's where the decimal place is. Well, how many tens do we have to multiply by to get all the way over to 2 million? Well, we move the decimal place over once, twice, 3, 4, 5, 6 times. Okay, so we have to move the decimal place over 6 times, which means it's 2 times 10 to the 6th. That's what 2 million looks like in scientific notation. Okay, now what about 0.005 or 5 thousandths? Okay, well, we're going to use 5 times 10 to the something. Okay, we're going to be a negative exponent here because we're moving to the left. But remember, for 5, the decimal place is here. You move it to the left 1, 2, 3 times. So 5 times 10 to the negative third power. Alright? Now, we can have decimals, as I said, in here. So for 539,000, we're going to use the number 5.39. And we're going to multiply that by 10 times something. Okay? But 5.39 means we've got the decimal place here, and we need to move it. How many times do you get to 539,000? 1, 2, 3, 4, 5 times. So 10 to the 5th. So 5.39 times 10 to the 5th gives you that. What about this giant 0.0000574? Okay, well, we need a number between 1 and 10, so we're going to use 5.74. times 10, okay, now 5.74 puts the decimal place right here. Okay, so to get our 0.0000574, we have to move it over 1, 2, 3, 4, 5 times to the left, so it's to the negative 5th power. Alright, last two here, we've already got written in standard form, and we're just going to rewrite them in standard form, right, the original way, just the way the number is. Okay, so you're just going to write the number, but move the decimal place over to the right every time that number if it's positive, to the left if it's negative. Okay, so for our first one here, 2.0075 times 10 to the 6th, we need to move it 1, 2, 3, 4, 5, 6. We need to add 2 zeros onto it. So 2007500. Okay, put your commas in there, and we have 2,007,500. Right? And lastly, 4.5 times 10 to the negative 4th, we need to move this decimal place over 4 times to the left. 1, 2, 3, 4. Okay, we see here that there's 3 blanks, so we got to add 3 zeros after the decimal point, right? But we need the 0 in front of the decimal point also, so we have 0.123045. Okay, and that's the answer. Let's go to the examples. Alright, so write a couple more in scientific notation. Okay, the way we're going to do this is, right, 2.675. We don't need all those zeros. okay, times 10 to the how many? Alright, well, if we put the decimal place here, we've got to move 1, 2, 3, 4, 5, 6, 7, 8 times, so it's 10 to the 8th. And that's it. This one, okay, we've got 0.000486, so we're going to use 4.86 as our number between 1 and 10, times 10 to the, if the decimal place is right there between the 4 and the 8, we need to move it to the left 1, 2, 3, 4 times. So to the negative 4th power. Alright, now write a couple in standard form. 7.0234 times 10 to the 5th means we're going to move the decimal place 1, 2, 3, 4, 5. We need to add a 0 on. So we have 7, 0, 2, 3, 4, 0. Add your commas in there. And we have 702,340 is the correct answer. Now for number 4 here, we're going to have to move the decimal place to the left. So if you think about it, we're going to move it to the left 6 times. We got 1, 2, 3, 4, 5, 6. Okay, we're going to have, you see 5 blank spaces there. Then we need to fill in with zeros, right, after the decimal point. So we need our 0 point first, then add your 5 zeros, 2, 3, 4, 5, and the 3096. Big looking number, but it's a really small number. Okay, now number 5 here is a little bit different. We're going to order these 3 numbers, 93,000,000, 9,028,000, and 9.2 times 10 to the 6th, from ordering from least to greatest. Okay, so in order to do that, what we're going to do is we're going to write all of them in standard form. Or not standard form, we're going to write all of them, well, either way it works. You could either convert them all to standard form, or you convert them all to scientific notation. Okay, this one, because we've got 2 in standard form and 1 in scientific notation, it probably makes most sense to just change the one from scientific notation right back to standard form and then compare them. Because it's obvious to us that, right, 9 million is smaller than 93 million. But just so we know how to, I think you guys can compare numbers like that, I'm just going to show you how to compare scientific notation. So I'm going to change both to scientific notation. Okay, so this 93 million, we're going to change to 9.3 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. And the 9 million, hopefully you notice something so far, I'm going to change to 9.028 times 10 to the 1, 2, 3, 4, 5, 6 power. Okay? So, one thing you should notice here, right, the one that has, if they don't have the same exponents, right, this one's got 7, that one's got 6, that one's got 6, the one with the 7 is definitely going to be the biggest number. Okay, so we know that that's going to be the largest one. Okay, so I'm going to put order from least to greatest, so I'll put 9.3 times 10 to the 7th at the bottom, because I know that's the biggest one. Alright, now which one's smaller, 9.2 times 10 to the 6 or 9.028 times 10 to the 6? Well, once you get there and they have the same exponent, right, you basically are just going to look at the two numbers and see which one's the bigger one. Well, 9.2 is bigger than 9.028, so 9.028 is going to be on top. 9.028 times 10 to the 6th, and 9.2 times 10 to the 6th. Okay, that's the order from least to greatest. Now, evaluating with these last 3 problems, we're going to be multiplying, squaring, and dividing in scientific notation. Okay, so in order to do that, basically, it's pretty simple. Okay, with the numbers, you actually do the operation. So here you're going to multiply. This one you're going to square. These two you're going to divide. Okay, you actually do the operation, and then with the exponents, you just use our exponent rule. So with these exponents, you're multiplying 2 exponents, so you're going to add the exponents. With this one, you got power to a power, so you'll multiply them. And with these two, okay, you're dividing exponents, which means you subtract. Okay, so let's go ahead and do that. So 5.7 times 2.6, you just got to use a calculator for that. Or, I mean, I guess you don't have to, but I'm going to. 2.6 gives us 14.82. 82 times, right, 10. Add the exponents, 3 plus 4 is 7. Okay, so we got 14.82 times 10 to the 7th. You should see that there's a problem with that. Okay, this is good, but the problem is 14.82 isn't within our bound between 1 and 10. It's bigger than 10. So we need to move this decimal place one more time over. Okay, so if we're going to move it one more time to the left, to get our actual answer, we need to add 1 to our exponent. right? Just think about it for a second. If you're moving from here 7 places, if you're going to move from here, you're going to have to move 8 places to be the exact same number. Okay, so that's what we're going to do. We're going to change this to 1.482 times 10 to the 8th power. It might be complicated for you, so you might want to go back and rewatch that again. Now, to square this, okay, we square the 2.4, so you can do that in your calculator or on your paper. You should get 5.76. Okay, and then to do the power to a power, you multiply -4 times 2 to get -8. And we've got 5.76 times 10 to the -8. Luckily, this is between 1 and 10, so we're good to go. You can just leave it like that. And the last one here, you divide your 2.4 divided by 2.5, and you'll get 0.96. 0.96 times 10 to the, right? When you do subtraction, right, when you do division like this, you have to subtract the exponents, so we've got to do 5 minus -4, which is the same as +4. Okay? So this is the same as 0.96 times 10 to the 9th power. Alright? Now the problem is, this number here, 0.96, is smaller than 1. Can't have a 0 point. Right? So we need to move the decimal place over 1. If we're going to move the decimal place to the right, this time, we're going to take 1 away from this number. Right? Because if you start here and you move the decimal place 9 times, right, in order to get the same number from moving the decimal place from here, you can move the decimal place 8 times. Okay? So the final answer here would be 9.6 times 10 to the 8th power. All done, guys.